Hello, in this rather short talk, we're going to have a look at jumping in the context of an AI-controlled entity. Depending on the game, for example, if it's a platformer game or some side-on game, you may actually want to enable your AI-controlled entities to jump within that particular environment. Jumping, I mean, it fits in well with the steering behaviours and by way of one of the mechanisms by which a character can move itself around the environment. Steering behaviours, things like seek and separate and things like that, they're quite nice because they can adapt to a particular situation. Because they're run several times every second, they'll keep checking their assumptions and recalculating directions, so that even if they're slightly off, they'll be slightly off for a fraction of a second, and then they'll sort of fine-tune their particular solution. So in that sense, they're quite forgiving. Jumping, however, is a completely different kettle of fish. When you jump, you commit to the jump. So as the decision happens at a point of time, and then where you land is played out thereafter. So it's a one-time, single event, fail-sensitive decision. You can jump and you can get it wrong. So you need to be careful when you decide, I'm going to jump, that you have adequately planned where you're going to land, that you're not doing it in a overly risky way. Depending on the game, you know, it may or may not be an issue, but we don't want our AI-controlled characters to be overly suicidal in terms of their behaviour. In essence, for a safe jump, we've got to be moving at the right speed in the right direction. So it's as simple as working out what's the direction, what's the speed, and then a little bit about when we actually execute the timing of the jumps. There are different ways to handling this, and jump points are a fairly flexible way and a quite a simple approach as well. So one way of doing this is to put within the level, this is by the designer, a region where you basically enable the AI controlled agents to say, if I'm within this region and I jump, I can safely jump to the other side. So you indicate the bits in which the character is able to jump. This removes an awful lot of extra complexity that you would have of an agent trying to work out what's in the environment, which bits it can or can't jump over. So it puts the burden on the programmer to designate a number of safe spots or appropriate spots from which to jump. As we mentioned, okay, we've got a direction of jumping, we've got a speed of jumping, so that if it's important for characters to be moving with a certain speed, you can also encode this into the jump pad. You can say that if you've hit me and you're traveling this speed or above, then feel free to jump, and it'll take you across to the other side. So in that sense, we can seek towards that point, we can jump when we get there. It wouldn't be programming if there wasn't some forms of difficulty associated with this. I'll give you a couple of examples here. So we've got a character at the bottom, and for this type of platform, now it's important that we get the speed right, that we're not too slow, we'll not race the platform, that we're not too fast, we'll jump over the platform. So this one here is a little more sensitive to the direction of approach, but it does require the speed of the jump to be finely tuned to land on the platform. In this other example, here we have a situation where we need to be reasonably precise in the direction in which we approach it, but as long as we've got the direction lined up, as long as we're not too slow, we can be faster if we want, we can jump at anything above our minimum jump speed. So two different situations which actually can be combined together, where you have some jumps where you have to be precise in terms of direction and precise in terms of speed. How do you get around this? There is actually quite a nice extension to jump pads, and it's to add in the notion of a landing pad. So you have a pair of pads then, one that you can jump from and one that you can then jump to. And arguably, from the other side then, jump pad and landing pad, they sort of reverse their particular roles. The reason this is nice, and this ties into one of the previous talks that looked at working out the trajectory of something, where we were talking about throwing, for example, a ball or shooting an arrow, where we plan a direction, want to work out where it is going to land. So effectively, this is a similar situation here. We've got a starting point, we've got a destination point, and we want to work out, for example, the speed or the direction at which the object wants to throw itself, or wants to jump and move its whole self so that it leaves the jump pad and actually hits the target landing pad. So we can actually take the types of algorithms that we had within the aiming solution and use it here for the character to work out direction and speed of approach so that it can then safely jump from the one path to the other. Very flexible. Different characters then can take into account, okay, how fast can I accelerate, and do I need to take a running jump at this, what direction do I need to come in, but it lets you do this safely and also quite flexibly. So short talk, key takeaway in this, if you're thinking about doing jumping, there are different ways of doing it, but jump pad, landing pad, that gives you a nice degree of flexibility. There's a good balance between encoding safe options within the level, but by using things like the firing solutions, giving a lot of flexibility to agents in terms of making sure they can do these things safely.